Good morning, everyone. Good afternoon or good evening, wherever you are. And welcome to this Climate and Atmosphere podcast on Saharan Dust Storms. I'm your moderator, Dimitri. I'm a contractor to the European Centre for Medium Range Weather Forecasts, who are the hosts of this podcast. ECMWF is in charge of implementing the Copernicus Atmosphere Monitoring Service and the Copernicus Climate Change Service, which are part of the EU's Copernicus program, Europe's Eyes on Earth. Today, we'll be discussing dust storms from the Saharan Desert, how they impact Europeans, and why it's important for us to monitor them. And with me today are four scientists who will help us to understand all of this. So, on the panel with me today, I have Sara Basart from the World Meteorological Organization's Global Atmosphere Watch program. Hi, Sara.
Hello, Dimitrios. Hello, everyone.
I have Elena Ruiz Donoso from the German Aerospace Center, DLR. Hi, Elena.
Hi.
I have Melanie Ades from ECMWF's Copernicus Atmosphere Monitoring Service. Hi, Mel. And I have Mark Parrington from ECMWF's Copernicus Atmosphere Monitoring Service. Hello, Mark.
Hi, Dimitri.
So, Mark, we're talking about dust being blown around from the desert and ending up over European territory, right?
Yep.
So can you tell us a bit more about this phenomenon? I mean, how bad is it? What's the severity of these dust storm events?
Okay, well, they're occurring because of changes in the wind patterns over the desert. There's some very specific source regions where mineral dust gets lofted into the atmosphere, and then under the right wind patterns, it can be lofted over the Canary Islands and recirculate over the North Atlantic, or it can cross directly across the Mediterranean to affect southern Europe, but also central and more northern parts of Europe on occasion. And most people will typically experience this as hazy sunsets or sunrises, but the closer you are to where the dust is coming from, the more likely there is to be deposition to the surface. I'm sure many people have also experienced sort of reddish, purplish dust on their car after rain when these events have been occurring. But then there are also health impacts as well. And I think Sara has spent a lot of years looking at this, and I learned a lot of what I know about dust from Sara and the in-dust cost action of the last few years. Yeah.
Super. Okay, good. So not just the beautiful sunsets or the hazy skies, which one might enjoy, but then the additional burden of cleaning your windscreen. And I'm sure there are a lot more serious matters to do with health. So perhaps, Sara, could you tell us a bit more about what you do and how and why Saharan dust storms in particular are assessed?
The World Meteorological Organization is the United Nations agency specialized in weather, climate, and water. And in this context of climate change that we are living, dust is one of the elements of the Earth system that is getting more and more attention because it's one of the most abundant aerosols in the atmosphere. And when we think about dust, sometimes we are thinking in Sahara, that is a huge desert that is transporting these amounts of aerosols toward Europe, through the Atlantic, arriving to Barbados, and is a very key element of this Earth system and this balance of processes that are connected with the atmosphere, with the oceans, with the land. Everything is connected. Keep in mind that the nutrients coming from the dust, the iron and the phosphorus, is transported until crossing the Atlantic, arriving to the Amazonas, and is one of the nutrients that is giving this big forest to the Amazonas. Then you can see that it's a global phenomenon. Even if it's starting in one desert, it's spread around the world. And for this reason, it's so important in these international conversations.
Wow, that's really interesting. So you're saying that the Amazon is actually fed and nourished by dust and minerals that come from the desert, from across the ocean.
Exactly.
Wow.
Yeah.
Super interesting. Okay. So what do we consider to be an exceptional event insofar as this dust transport is concerned?
Exceptional is everything that is causing something extraordinary in your daily life, right? Then when we talk about exceptional events, it's something that is maybe closing airports, or even it can be something that is reducing the visibility so much and you cannot drive with a safe space because you cannot see beyond 2 meters, for example. And this happens when you have a very extraordinary event, like the one happening in 2022 in Spain, that was really extreme one, or the one in 2020 in Canary Islands that was like stopping and collapsing the air traffic during few hours, and this means cancellations of flights, for example.
Right. Obviously, those are, very impactful, and I think probably a lot of the listeners will remember seeing news headlines about this kind of thing. And of course, the general air quality is something that impacts people's health. What can you tell us a bit about that? I mean, what kinds of health impacts might there be from dust storms?
Obviously, when you are in the middle of a very strong one, you can feel in your skin and your eyes dust crushing you, you know.
Yes.
This is the most obvious one, but also there are some studies that also connect dust with respiratory diseases and cardiovascular diseases. But also on top of that, there are some pandemics, some diseases like meningitis in Sahel or the valley fever in the area of Arizona in the United States that are connected with the transport of dust. It's like transport is like a good agent to transport virus and bacteria. And this is something that is also connected with our health. Then WHO is doing a lot of efforts to really advance on this type of diseases and the connection with these atmospheric processes.
Okay, may I say that is terrifying, nothing short of terrifying. I'm never going to look at a hazy sunset the same way again. I'm going to be imagining all these agents of disease being transported in the clouds.
Something happens when air is in movement. Sometimes it's good. I mean, you can see something is good when Amazonas is receiving nutrients, and some things are not so good, but not really a critical situation.
Right. Thank you, Sara. Very interesting. So now I think we've got a very clear picture of why we need to observe these phenomena, these events, and possibly even try to forecast when they might occur. So I'm going to turn now to Melanie. Mel from ECMWF, can you tell us a bit about what you do and about the challenges of observing and of modeling dust storms?
Yeah, of course I can. So I work as part of the Copernicus Atmosphere Monitoring Service, and my specific role is in how we can use observations of aerosols to try and understand what is exactly occurring in some near real time to do with aerosols in the atmosphere. So we're looking all around the globe here. So that might sound a bit silly, but we perhaps, you can't look out of your window and see what's happening to do with desert dust in the Sahara. And so my role is to try and build up a sort of picture of what's happening all around the globe to do with aerosols right at this moment. And aerosols are things like desert dust, so they're small particles in the atmosphere, but they're also things like sea salt or smoke from forest fires. So I'm really trying to build up this sort of global picture of all these different aerosol phenomena. And we can observe these aerosols from satellites in space. And then we use these observations to try and understand where we have events occurring, such as desert dust storms. And this is really important because we have to know what's happening with the desert dust storm right now to then be able to forecast it forward in time. And so we can do this forecast forward in time because we know things like the winds. If you think about your weather forecast that you see on the news, it might tell you to watch out, there's going to be strong winds in your area tomorrow. And we can use exactly that sort of information to take what our desert dust storm is right now and use those winds to look at, first of all, whether a desert dust storm might be created. So if there's strong winds at the surface over the Sahara, then we might be forcing dust up into the atmosphere. But those strong winds will also control how then that desert dust storm is being moved. Is that desert dust storm going to go across the Atlantic to the Canaries to the Amazon rainforest? Is it going to be taken up across the Mediterranean? Is it going to cause the sort of phenomenon that we've seen, like the orange snow or dirt on our cars here in the UK? So those winds are very formative in telling us how that desert dust storm is going to change in time. And we can also model other processes. So things like how the desert dust is going to settle in time. So if you've got a totally calm atmosphere, that desert dust is heavier than the air. It will slowly settle out of the air and your desert dust storm will be over. And we model all of those sort of phenomena. We model on huge supercomputers. And then we can use the sort of data we get from these huge supercomputers to produce these forecasts moving forward in time of what's going to happen with desert dust. So here at CAMS, we produce various different products. We produce analyses, which are like snapshots in time of what aerosols are doing all around the globe at any one specific moment. But we also produce these forecasts. So we produce 5-day forecasts that we release twice a day. And they'll tell us what, say, desert dust is going to be doing over the next 5 days forward into the future. So those are two of our products. We also produce things like historical records. So we produce a long-term historical record of desert dust that goes from 2003 to the present day. And that's also useful information that people can use for real users in life, can use to understand what's going on. And we also, in addition to that, monitor these events. So this is returning to what Mark Parrington was talking about, of sort of monitoring extreme events in near real time as they happen. So these are all the sorts of products that we have as part of the CAM service.
Super. Well, thank you. So that's a great overview of the full picture. So you've got your sort of short-term, near real-time observation, what's happening right now. You've got a forecast stretching out over the next 5 days, and you've got a historical record that can be used to sort of do further analysis. Just to take a small step back for our viewers. So the word aerosol, we mostly think of things in a can as, layperson. And that, of course, just means that it's being turned into something that be carried around in the air. Is that right? Is that the definition we've got here, is that it's
well, we tend to think, small particles that are suspended in the air. So desert dust is a perfect example. It's a small, it's sand, it's dust, and it's lofted up into the air. So desert dust obviously is at the surface, but when we think of a desert dust storm, we're looking at that desert dust being suspended in the air.
It basically flies like a little kite, kind of being floated around, right?
Exactly.
In the air.
Yeah.
And
yeah.
You said that the dust, or the aerosols in general, but specifically somewhere like that, can be monitored from space via satellites. Now, this I find fascinating. Could you tell us a little bit about that process? I mean, how does that work?
Of course, yeah. So what satellites actually measure is they measure the radiation from the sun that's being reflected by the Earth, if you can imagine that. So they can measure this radiation, and then we have an idea, we have an understanding from physics of what in a totally clear atmosphere we'd expect that radiation to be. But what we have from the satellite is what the radiation actually is. And at certain wavelengths, that radiation will be impacted by things like desert dust. So if you think about a forest fire, huge amounts of smoke coming up into the atmosphere, they're going to stop the sun reflecting the radiation. They're going to stop the radiation from the sun being reflected back up to the satellite. So we have something that's interfering with what we would see if it was a clear sky. And we can measure that difference, and that gives us information about the fact that there is something in the way there. There is an aerosol in the way there, or a cloud. Here's one of the difficulties of doing these measurements. We don't know for definite. We don't know what type of aerosol it is, and we don't know whether it might be a cloud as well. So there's a lot of work that goes into really trying to understand those observations, to separate out the clouds, to look at what is on the Earth's surface and how that will impact the radiation we see being returned. And all that information is sort of used to create this observation of an aerosol that we can see.
It sounds like a very difficult job indeed. And so basically what you're saying is that the sun reflects off the Earth. We know what that should be like if there were nothing in the way, and then we compare it with what we actually measured, and there is stuff in the way. It's all sorts of things are in the way.
Yeah.
And then once you know that there is something in the way, you can try and figure out what that something is.
Exactly that, yeah.
Okay, just a critical question here. How confident are we that what we're measuring is the phenomenon that we're hoping to measure? So when you say we've filtered out everything else and what's left is dust, how confident are we about that process?
Well, so the first issue is that we're not necessarily confident it's dust. So we're confident that it's an aerosol, I would say.
Yes.
And so then one of our things that we try and do as part of the Copernicus Atmosphere Monitoring Service is try and work out that we have a forecast that tells us it should be dust. So we think it's dust there, and we can change our dust field. So if we, for instance, don't have enough dust, we can change our dust because we have this observation that there is an aerosol there. That makes sense. But you might get to difficulties if you have a plume from a forest fire, smoke plume, and dust together. Then we have difficulties trying to say, well, is what we're seeing a change in the sun's radiation because of dust or because of smoke? So that's the difficulty. In terms of saying how confident we are that it's an aerosol, a lot of work goes into these observations and understanding these observations, and they are analysed and quality controlled, and they come with an uncertainty measurement. So we're relatively confident in using them. There might be issues such as biases, but again, we can work with that within our system and understand the sort of where they might not be quite so accurate or they not do so well. That can be part of our system. So we're reasonably confident at using them.
Are there any non-space based detectors that can add to our understanding of these things? Is there ways to measure this stuff from Earth as well?
So yes, is the short answer. I work as part of the CAMS global service. So this is the global model. And we use what we call in situ observations. So these are station observations. And we use those for verification. We use them to look at how well our observation is doing. We're starting to look at whether we could perhaps use some of these observations within our system. They measure slightly different things. So we'd often look at sort of either measurements of PM values, so particulate matter. So again, we don't know quite what that particular matter necessarily is. So we're using different types of these observations. But the regional models actually will look at using this within their system. So the regional models form part of the CAM system as well. These are localized European models that just provide forecasts and analyses for the European domain, and they'll look at trying to use those observations within their system.
So there's a global model, and then there's also regional models which are more specified on the actual characteristics of the specific area. Maybe, Sara, could you comment for us on how WMO actually is addressing some of these challenges? Don't forget to. There we go.
Okay. No, I was listening to Melanie, and in fact, CAMS, Copernicus, ECMWF is one of the players in this international cooperation to really provide accurate information for stakeholders on aerosols, reactive gases, and greenhouse gases, meaning that all the work that Copernicus is providing to the community at global and regional scales is also a benefit for the international community, for the global community, because these global systems are providing information in those areas of the world where we are not having infrastructure for monitoring air quality, for example. And here it's important to emphasize that we need to integrate information from satellites, ground-based networks, meaning air quality networks, because sometimes satellites are not enough good to provide you the information on the surface, where is the part of the atmosphere where the people is living and you're breathing this air. Then modeling satellites and networks has to be integrated in a framework that at the end, the outcome is to provide the most accurate information that we can provide for the different user communities as energy, transportation, aviation, health, also youth, agriculture, any communities having some impacts because the presence of aerosols as dust or even smoke, as Melanie mentioned. Then it is very important all the work that Copernicus through CAMS and through ECMWF is doing for the community. Yeah.
Thanks. And Mark, could you perhaps comment on this from your point of view?
Yeah, of course. So I didn't introduce myself, but I also work with Mel in the Copernicus Atmosphere Monitoring Service at ECMWF. And what I do there is essentially the on-the-fly evaluation of our forecasts and analyses to identify events so that we can communicate about them, but also to see if we have any technical issues or there's things that we can fix in our system to make them better in the future. And so this covers desert dust is a large part of that, because I'm looking at our aerosol forecast, but also fire emissions, smoke, transport, any other kind of atmospheric composition or air quality event. As my day-to-day work is looking at those things. So I make use of whatever information we have available at the time from these ground-based and in situ sensors that Mel talked about. And that gives us a sense then of how confident we can be in our forecasts about how it evaluates that in different parts of Europe or different parts of the world. And of course, depending on where you look, there's a different density of these kind of observations. So in some cases, we know we do very well. And then we kind of extrapolate that to say, well, in those places where we don't have so many observations, we hope that it's a similar kind of evaluation. But of course, having more independent measurements is essential to being able to properly verify and evaluate that. So yeah, the work I'm doing, there's the two sides of it to try and interpret the forecast. So we have a total aerosol forecast, and then to try and pull apart, this much of it is from dust, this much is from smoke. We also have various atmospheric constituents and pollutants in our forecast, which can also help to try and disentangle this. So things like carbon monoxide from smoke can help us with those cases. And then there's things like volcanic eruptions, sulfur dioxide can lead to sulfate aerosol, which is another part constituent of that aerosol optical depth that we have a forecast of. And that helps us then to communicate to users to say, this data's here, this event is happening now, this is how we think it's going to evolve over the next few days and what the possible impacts might be. We do that through our website, through social media, but also then to feedback to the technical developers, people like Mel and other people in the team who are actually doing the work on improving the model, doing the forecasting, doing the observations and the assimilation and everything.
Okay, thanks. Wow. So we've got an incredible infrastructure here that can really do an awful lot in the way of actually looking at not just dust, but all kinds of things that are floating and carried around in the air, in the atmosphere at different layers. And as Sara said, it's very important that the part where people are breathing in the air is the one that we're interested in from the point of view of people's health. But let's look at one particular aspect of this, which is very important, and that is the solar energy sector. So, Elena, could you introduce yourself and tell us a little bit about how solar energy is impacted by dust storms?
Yeah, sure. So I'm Elena Ruiz, and I work at the Institute of Solar Research of DLR. And we are based in Almeria, in the south of Spain, because we use the facilities of the Plataforma Solar de Almeria, which is owned by the Spanish Research Institute CIEMAT, and is one of the largest facilities in Europe to test and development of solar technologies. And within the Institute of Solar Research in DLR, I am part of the Solar Energy Meteorology Group. And what we actually do is we test how different meteorological parameters impact the energy production in the solar energy sector. And just as a comment now, because you were all talking about the validation of the product, of the CAMS products, we also provide ground-based observations for the validation of the deposition product. So regarding your question on whether the Saharan dust intrusions can be observed at the ground, so we clearly observe them with a particle counter, which is what also Melanie mentioned, the particulate matter, so like the amount of particles that are present on the atmosphere. And that's just as a side comment. And back to the impact. Yeah.
So I was just going to say that what you're saying, the particle counter, is that just a thing that collects dust as it falls down? Like you're just trapping the dust?
So there are different ones. And so there are ones which are based on filters that actually collect the particles that fall down. But the ones that we are having in, it actually... it works on light scattering principle, so similar to what happens with the satellites. I mean, in the end, it's an aerosol particle scattering the light. But in this case, the instrument itself, it absorbs air continuously, and it emits light with a laser, which impacts on the aerosol particles, which are in that volume of air which was absorbed. And these aerosols backscatter the incoming laser, and with that, reflected or backscattered light, we can count how many particles there was in that volume of air. So as a similar problem that Melanie was mentioning, we do not know what kind of aerosol it is, but we do know the number of aerosols that we have. And based also on the particle size distribution, then we can derive, we can have some hints of what kind of aerosols we are dealing with. But already with the number of particles, that's already a very important parameter, also for application in the solar energy. And with that, I would come back of the effects of dust in the solar energy. And dust it's a very important parameter because it reduces the amount of incoming radiation to the solar panels in two ways. So Mark already was also talking about this, when we have an extreme load of dust in the atmosphere, then there are these cases of red skies. And I think we all can relate to the fact that when those events happen, we actually cannot clearly see the sun, or we can directly look at the sun and it doesn't hurt as it normally does, which means that the amount of direct sunlight that we are receiving is much less. So just by simply redirecting the light that is coming from the sun, that means that less solar light is arriving to the panel, and therefore less light is being less energy is being produced by those panels. On the other hand, at some point, these particles that are suspended on the atmosphere, as it was already mentioned, they deposit onto the solar modules. And that means that we have opaque particles on top of the solar module, which prevent the sunlight again reaching the solar module itself. And this is a very well-known problem in the solar energy sector. It's called soiling. And therefore, whenever we have Saharan dust storms, this is a very important thing to have into consideration. And now the CAMS forecasts are really important for the solar energy sector in two ways mainly. So during the life of the power plant, they are taken into consideration first before the power plant exists itself, so during the design phases, in order to evaluate whether a location is suitable for a power plant or not. Because so if it's a region that is very frequently affected by these dust intrusions, then maybe the energy production that we can get out of this power plant is not sufficiently high, or the economical benefit that the power plant owner would get is not sufficiently high. That on the one hand, but on the other hand, so when the PV modules get soiled, so like they have dust on top of them, in order to come back to a higher energy production, they need to be cleaned. But this cleaning also comes with a cost. And therefore, the operators and the power plant owners need to decide a trade-off, so a compromise between the energy that they are losing due to the soiling on top of the panels and the cost of the cleaning the panels. And using forecasts of the aerosols that there are in the atmosphere, then we can reach an optimized cleaning schedule where there won't be such a big economical loss, and also taking into consideration that power plants are very often placed in dry regions, and we also optimize the water consumption, which is a scarce resource in these regions. And now, once I've talked a little bit about the importance of the CAMS forecast, we are kind of the intermediate user between CAMS and the solar energy sector. So the parameter that the users in the solar energy sector are interested in is not the load of aerosols on the atmosphere, and it's not the amount of particles that deposit on the PV panel. They are interested in a magnitude which is called soiling ratio, and which is just simply the comparison between the energy production of a dirty panel compared to a clean one. So like we take the energy that is produced by a dirty panel and we divide it over the one that would produce a clean panel. And this is, of course, very related with the amount of particles that are depositing from the atmosphere. And that's the work that we do. We use the CAMS data to provide forecasts of the soiling of the PV panels. So we are developing a soiling model, this called. And doing this mathematical transformation, then we are able to provide to the users these soiling forecasts that would allow them to optimize the cleaning schedules. Or in the case of design phases of the power plant, they would allow them to make an optimal decision about the location of the power plant.
Elena, thank
Yes.
you. So this is a fascinating subject. Just to sort of unpick a few of the points in here. Now, just to help us who don't work in this industry to understand, obviously it would be great if you knew in advance that your house was going to be dirty, and then you would bring the cleaner on that day to clean the house. It's a kind of a similar thing here, but I think what we need to understand is the scale of these things, right? So we are talking about cleaning not just a window, but we're really talking about many, many square meters of photovoltaic panel area, right? That glass that needs to be then cleaned free of dust. So we're talking about a lot of money that comes into these operations. Is that right?
Yeah. So I am not an expert on cleaning costs. We do not deal with those with those services.
Mm-hmm.
But I was checking up some numbers which are in the literature, and it's very interesting how different it is also to clean like a couple of panels that somebody might have installed at the place. So that depending on the country, but in Spain it can be like 100 or 200 euros. I don't think individual users would benefit of this forecast, but they could contact us and then we would provide them. So what's really interesting is the power plants, and there the cost per square meter is much lower, but then we need to have into consideration that, as you said, the amount of PV panels is incredibly large. So doing some research, I found like a medium power plant can have up to 100,000 PV panels, which I found shocking. And they are a bit larger, but if we consider that each PV panel has a 1 square meter, and the cleaning cost may range, depending on the country, from a few cents, like 20, 30, to 1 or 2 euros. So I'm just going to choose like 1 euro to have the easy calculation. Then we are talking about 100,000 euros for cleaning the whole power plant. And if this is done several times among the course of the year, then it's quite an important investment for the company.
Absolutely. And I think what you're saying as well is that if you have a forecast and you know that there's going to be a dust storm, you would avoid spending all of that money, all those hundreds of thousands of euros, until afterwards, and make it worthwhile. Sara, can you comment on this?
Yeah, it's interesting because Elena is pointing a lot about the cleaning part, but also there is other cost, other losses connected with Saharan Dust Storms and energy production, because as she mentioned, you have the less light that is arriving to your panels, and we have the energy market, and you're selling energy based on this estimation on your production that is having this component of how efficient you are for producing energy that is based on the arrival of light to your panel. Then the cleaning is important, but on top of that, you have also the light that is available to arrive to your panel. And I can tell you, in some extreme events, it's millions of euros that you can lose connected with the energy production itself in the market. Then it's a very huge sector, yeah.
That's right. So one has to make a decision. Should I spend 100,000 euros or more to clean and then gain back from that some additional energy production? Or should I wait a little bit and so on? And I think it's very important to point out that at the scale of these decisions, the information that is provided that enables you to choose the right way is incredibly valuable for the power plant operators. And of course, there are these other impacts which are of vital importance. The water scarcity point. I mean, it takes a lot of water to do these things, and water is, an absolutely invaluable resource, and we shouldn't waste it. And then, of course, the very fact of delivering less power into the grid and the impact on the energy market. So this is super interesting.
Mark had mentioned maybe about the CAMS solar product, which is also related with the solar energy, right? Okay, Melanie. do?
I don't know. So we don't just have a dust product. We also have a radiation product, which is a product that users can use, but it's more of a historical product. So that's not at the moment, it's not a forecast, but it's a look over the historical period of a specific location. You can look at what sort of solar radiation you can expect at one particular location. So that's also a product that we have available from CAMS. That's also useful to the solar energy sector, but perhaps is not used in quite the same way as the forecasts that we use to really help solar providers sort of make judgment calls about what they want to do with their power plant in terms of cleaning it, in terms of selling the energy. And in that way, I think it's very important that we reiterate all the work that goes into our quality control of our forecasts. And I don't know, Mark, if you want to talk a bit more about the quality control and how we look at our forecasts and ensure that they're accurate for use by the solar energy sector.
Yeah, of course. Yeah. So the work I'm doing, which is the day-to-day on the fly, if you like, evaluation, this is really that right now and over the next few days, how confident we can be in the forecast. But this is only a small part of then the overall validation of all the different products that we have in CAMS, because there is a contract which delivers three monthly validation reports of all the CAMS products, and that's done on a much larger scale across Europe and a bit more globally as well. And it brings together the dust and the particulate matter and evaluates against a wide range of independent observations. And all these reports are made available on the CAMS website. So at the bottom line of what we're doing in CAMS is really providing fully open access data. There's a component of that which is then showing users that the data's there, and also how much confidence we have, because we're making this on the fly evaluation, but then also this larger scale validation. And all this information is then available from our website, so users can go and take the data and see for themselves or develop their own applications, knowing that we have confidence in the product that we're providing. And as Elena said, the costs and the requirements for being able to have this information and having good quality and understanding the quality of the product is really essential. And so it shows. The work I'm doing is basically the end product, and I'm an interim user almost in a way, even though I work in the service. All those developments that Mel and other people in the teams and other contractors across Europe are working on to continually improve our forecast system and the observations and how we make use of those observations, all adds up to being where we are to be able to talk about it like this and make it sound relatively easy. But of course, there's a lot of things that have gone into it to get to this point.
Excellent. Well, thank you. So I would like at this point to remind everyone who's listening that there is information about this service on atmosphere.copernicus.eu, which is the website of the Copernicus Atmosphere Monitoring Service. We've been referring to that as CAMS, which is our acronym. On the page relating to this event, there are a couple of links to articles, previously published articles on the CAMS website about extreme phenomena. There's also a host of other resources that are made available on that website. If you're interested, of course, you can access the data as well. So now I'd like to see if we have any questions from our audience. I just have a look here and see. Perhaps, perhaps one for Sara. Can you tell us a bit about what you mentioned before? So, the topic here is Saharan dust storms, right, from deserts, but perhaps you can tell us a little bit more about other sources of dust in the atmosphere.
We know very well Sahara, but you know that there are other deserts around the world, like Tamaklan or Gobi in Asia. We have huge deserts in the Middle East. Australia is having some sources of dust of deserts. There are some deserts there, but also North America. There are a region close to the west coast, that is Arizona, the area of Arizona Phoenix, that is also having time to time strong desert storms. And South America, also the Atacama Desert in Chile and some regions in Argentina is having some hot spots of dust emissions. But now with climate change, we are having a new paradigm of deserts that are the cold deserts. And in Europe, we have the best example, that is Iceland. That is the largest desert in Europe. And it's not the calorie and tropical desert that we are thinking when we think in Sahara. Is completely different because it's a desert and the soils are based on volcanic ashes. Then try to imagine that the mineralogy, the composition of the soil is completely different, but still is a source of sun and dust because the process is wind emitting this huge amount of available soils on the ground. And this is something connected with climate change because, of course, ice is melting. The cryosphere, the ice cover of the high latitude areas of the world is being reduced, and is starting to emerge this new topic of research from the community, which is this new type of deserts that I'm sure that Copernicus people is looking at, because it's part of the things that you have to incorporate in future in your forecast, because people is living in Iceland, for example, or in Scandinavia. Then these areas is starting to be a new areas that are affected with these new emissions of dust that are not deserts, but still is an emission of dust. Because you have to keep in mind that for us, dust is everything that is uplifted to the atmosphere due to the presence of strong winds and some conditions of the soil. Then things that we have to be in mind when we think also in climate change. It's not just increasing temperatures, it's also how these temperatures are causing these impacts in another parts of their system.
Thank you, Sara, for that insight. Mark, perhaps you'd like to comment?
This is essential. How scientific research activities on current dust and how the sources are changing can feed into then an operational service like we provide in CAMS. So I talked about the continuous work to improve this. I think being able to specify the sources correctly is essential, and it relates to what Mel told us about being able to identify an aerosol observation where it's coming from. And so if we don't have the source, our forecast doesn't know, and so we don't have that first guess of what an aerosol observation might be showing us. And just on Iceland, this is a great example. In CAMS now we have something called the National Collaboration Programme. There's a contract with Iceland, and that will be specifically looking at dust measurements and evaluating our regional forecasts for the dust parameter as that contract develops. So it's definitely something that we have our finger on the pulse of, and that we're always looking to incorporate this additional information in our system.
Thank you. Well, listen, this has been a fascinating 45 minutes, just creeping up to the end of our time frame here. If anyone else would like to make a final comment, then now's your chance. Otherwise, I would like to thank everyone who tuned in and listened to this discussion today. And I'd like to recommend to you, if you're interested in more, to follow at Copernicus ECMWF on X, and to subscribe to the CAMS newsletter. And of course, to look out for the next podcast in our series. So I'd like then to thank my panelists today, Mark Parrington, Sara Basart, Melanie Ades, and Elena Ruiz. Any last words from any one of you?
Thanks a lot for the invitation. My pleasure.
Great. Well, it was a pleasure having you, and really interesting discussion. So I wish you all the best, and thank you very much for joining us today.
Thanks very much, everyone. Very interesting discussion.
Cheers.